Hi, AP Econ students. So we want to make sure that we truly understand game theory as a model for oligopoly behavior, and we're going to do a prisoner's dilemma example, just so we get a little more clarity. So first off, it's a situation where we have two people that got caught selling drugs. It's going to be two people that get caught selling drugs. The first is going to be Ashley. First one's going to be Ashley, and the other one's going to be Matt. Ashley and Matt. Both these kids here were caught selling drugs, and so they have an opportunity to meet with the DA, and the DA clearly separates them immediately and tells the following story. Tells both of them separately that they're going to get 5 years each for selling drugs. They got caught. A separate discussion. They got caught, and they're going to get 5 years each for selling drugs. However, the DA notices, and from feedback from eyewitnesses, is that both Ashley and Matt look like suspects in a recent armed car robbery. In other words, a bank robbery, which carries a much stiffer penalty. And so he goes up to Ashley first and says, "Hey, if you confess to this armored car robbery, and Matt doesn't confess to that, you're going to get 2 years, and Matt's going to get 20. Okay? So if you confess and Matt doesn't, you get 2 and Matt get 20. However, just the opposite is true. If you deny that, and Matt confesses, okay, Matt is going to get 2 and you're going to get 20. Okay, so Matt will get 2 and you will get 20. However, I will say this, that if you both confess, you're both going to get 10 years. So basically you have deny, you have confess, you have deny, and you have confess. Okay? Just finish that right there. Okay, just put boxes across the names so we can delineate here. But just taking a look at this, you have some interesting things going on. The globally optimal solution would be here. It would be to have both parties deny. That would be globally optimal, okay, which would get them 5 years each. So that would be a globally optimal solution. But let's think about what's happening here for a second. If Ashley were to analyze, what would happen if Ashley denies and Matt denies? That would be a 5-5. They denied 5-5. Okay, that's good. What if Ashley denies but Matt confesses? Then Ashley's going to get 20 years. That's kind of suspect. You definitely have to roll the dice a little bit, but what you also know is that Matt knows exactly what you know. So if Ashley were to confess, she's either going to get 2 years or 10. And so clearly, given that, Ashley's going to want to confess. Likewise, Matt will do the same thing. Matt is likely to confess because Matt will either get 2 years or 10 years. So ultimately what will happen is they will both confess, and we'll end up in a situation right here. 10-10. 10-10. This is a Nash equilibrium, because a Nash equilibrium is the result of when each player in a game chooses the action that maximizes his or her payoff given the actions of the other players. We know for a fact that given the options that Ashley has here, okay, then knowing the same options of Matt, given that knowledge, the maximum payoff for Ashley is in fact confessing. Okay, same thing for Matt. It's not optimal, but it is non-cooperative. By the way, that's the AKA, or also known as non-cooperative equilibrium. They are separated. Ashley and Matt are separated. Therefore, given the choices and the choices of others, the optimal payoff that maximizes Ashley or Matt's payoff is in fact 10-10, to confess. So one of the other aspects that we need to consider, and this may be a question, is this game a prisoner's dilemma or not? Now, clearly, I used the fact that both of these folks here are doing illegal things and the DA is talking to them, and so they're in prison. But let's make sure we understand what would drive the deltas. In this case, the question is simple. Given that there's a Nash equilibrium of confession, is there a different outcome other than, in this case, both of them choosing to confess, that both Ashley and Matt could agree to make them better off? Clearly, the answer is yes. And that is, I'm going to put this in red, that is to, in fact, deny. If they could collude, if they could agree to deny, then they're back to the original charge, which they got busted for anyway. It would be their optimal decision. Therefore, this is, in fact, a prisoner's dilemma. So you got a situation where you do have the prisoner's dilemma. Okay? There is a optimal solution, provided that you can collude. Yet, without that, the Nash equilibrium is to confess. I hope that helps, and we'll talk more about it in class. Take care, guys.